through, and then we're going to pull out all the hrefs. So this is probably thousands of lines of code that you really don't want to run. So Python 3 URL links.py. And so let's start with a simple one, http://www.drchuck.com. And it reads it. Oh, that's actually the card one, because we got a whole bunch. Let's see if the Sugi one worked. It found that one. It's right after sakaiproject.org. Where is that? Is there another Sugi? Oh, no, it didn't find that one. That's kind of funky. Look, it found it wrong. But that's okay. So you see it found all these and did a lot of nice stuff for us. If we do it, Python 3 URL links.py and do the easy one, http://www.dr-chuck.com page 1.htm, we will only see one. And there we go. Now, the SSL is if you are looking at a page that has SSL, Python URL links to, so I'll go to like https://www.si.umich.edu, and that will get a bunch of links. And so you'll see, if it wasn't for that, so all kinds of stuff coming back, and if it wasn't for this bit right here and this bit right here, this HTTPS wouldn't have worked. And it's not that that website had a bad URL. It has a certificate that's not in Python's official list. And so the URL is okay. So that gives you a quick summary of using the Beautiful Soup library in Python along with the URL lib. Hello and welcome to Chapter 13, Web Services. So what we've been doing so far is we've been using the request response cycle. We've learned about sockets, we've learned about URL lib, and we've actually learned how to pull HTML and even flat text off the internet. But what we're going to talk about now is using that same request response cycle to retrieve information that is specifically designed for programmatic consumption, so that we had to have this Beautiful Soup, which sort of did a hack job or solve the hard problem of parsing HTML. But why not produce data in a format that makes good sense to a program, because programs want to talk to each other? If you recall, the whole idea of a socket is to have one application process sending data to another application process. And so if we think about this for a moment and we realize that we have all these programs, they could be written in different programming languages and they're all connected. And so they might want to send data back and forth through the network. PHP programs, JavaScript programs, Java programs. And so we have to decide on a protocol that is independent of any programming language. And we call that the wire protocol, because if you were to sort of take some connection and watch the exact characters that go back and forth, that's what you would see if you were monitoring the wire. So that's why we call that the wire protocol. And so the idea is that we have to agree on a format that is going to represent the data, and we can't make it a Python specific format or a Java format. And when we take the data from the internal representation, maybe a Python dictionary, to send it to the wire, we call that act serialization, and that is going from sort of the internal representation to the serial representation or the wire representation. And then here is an example of a person with a name and phone number with using less thans and greater thans. This is an XML example. And then in the far end, in a different programming language, it receives this and then deserializes it and then turns it into some useful structure inside that programming language. And so this is an example of a wire protocol that's using XML, and that's one of the formats we're going to talk about. Another format that we're going to talk about is a format called JSON, JavaScript Object Notation, and it is simpler and easier, but it's not as precise and descriptive as XML is. And so while you'll find that most of the things you run into, especially if you're talking to APIs of one form or another, you'll find that JSON is very common. XML still holds sway in places like documents. So if you look at docx at the end of a Microsoft Word document, docx means that it's an XML version of the representation of a word processing document. So the first thing we'll talk about is XML. So one of the two ways that we mark up data is XML, the other JSON. First we'll talk about XML. We'll talk about XML more for a longer time than we talk about JSON. XML stands for Extensible Markup Language. There was a number of markup languages in the 90s that were out there, ways to send data between computers, and none of them was like amazingly better than the other, but in the early 1990s, as HTML came out, the idea that we could use less thans and greater thans, you know, or angle brackets, some people call them. Once HTML made angle brackets popular as a representation format, it was pretty natural that we would find a data representation format that would take a similar approach. And so inside XML, we're going to talk about tags, we're going to talk about attributes, we're going to talk about data, and we've already talked about serialization and deserialization. Serialization is the act of taking data inside of a computer in one programming language, setting it up for transport, transporting it across, and then taking it back apart and turning it back into the data in whatever internal data it needs to be in the destination system. So here is some basic XML, so we can take a look at the various things that make up the XML. So it's very much like HTML in that we have tags, less than, greater than. The difference is we get to name the tags anything we want rather than the A tag or the P tag or the H1 tag. And there's a beginning tag and an ending tag, and they're bracketed together. And there's syntax errors in XML. Syntax errors in XML are more severe than syntax errors in HTML. It's supposed to be right, and if you send bad XML, it's likely that the far end will not understand it. So we have a beginning tag and ending tag, and so like name and slash name are a beginning and ending pair. Then there is the actual textual content, and that is the material between it. And then here's a phone and slash phone, and we have this thing called the attribute. Key equals value. The key doesn't have double quotes. The value always has double quotes, and this is like href equals on an anchor tag. And sometimes you have what's called a self-closing tag, where you don't actually have a closing tag. You have all the data that you need in the attributes, and so you don't even bother putting an empty text area in a closing tag. So that is a start tag, an end tag, attribute, and then a self-closing tag. Those are some basics of XML. In general, XML doesn't care too much about white space. It does in the text areas, so in here it matters and here it matters, but things like we can indent this a little bit differently, and we tend to indent it in a way to make it look reasonable. Although once you have programs sending it back and forth, they tend to send it more compacted just for efficiency purposes. So one of the concepts is that there is a hierarchical structure within an XML document, and there are parent nodes and child nodes, and you can think of these as simple nodes that is a tag and some data, or a complex element that has a tag that includes other tags, some child tags. And there's a couple of different ways we can take a look at this. The simple and more natural way to think about this is a tree with parent-child relationships. So here we have this A tag on the outside, and that's the top level one. You can only have one outer tag, and you can't have, you know, another tag down here. So you have to have one tag that's sort of the root tag for everything in this XML document, and it has two children. So the C tag and the B tag are two children. So the B tag is a child of A, and then C has a D and an E tag that are children there, and then the textual data we model as a child of each of those tags, and you'll see in a bit why it's best to do that. So that is the way to think about this as a tree, to represent that XML as a tree. If we add attributes to it, and this is where you kind of see why it's nice to take the text area and make that be a child of the node, an attribute is a different. So the text is a special kind of child, and you can literally have more than one attribute. You could have x equals 2, you know, zap equals whatever, and these could have a couple of different attributes. The W attribute is a value of 5, and that's the 5 down there, and so you could have multiple ones. You can only have one text node. Now, in the case of A, you have a whole bunch of text nodes, but these are because there are child nodes. Within one simple node, you can only have one text element. You can also think of XML as paths, and the easiest way is to sort of look down this tree version and look at from the path from the parent. So you go to A, then the child B, and then X. So at position AB, you find X. So AB is the path up to the root. So ACD, that's this one,